This video introduces boot modes of RZ T2M, RZ T2L, and RZ N2L. It also shows you how to select the boot modes in FSP and the settings of RSK boards. Here are the abbreviations used in this video. RZ, T, and N are basically designed to boot a program stored outside the device in a flash memory. There are several boot modes, broadly classified as for reading programs from external flash memory or host CPU, updating firmware, and debugging available in FSP. In this video, the modes marked with red frames are explained. The following is a flowchart of the process of executing a user application with CPU 0. There are two boot stages. The first stage is called FSBL and the second stage is called SSBL. FSBL is the boot process that is executed after device reset is released and implemented in the device. SSBL refers to a loader program, which initializes the device after execution FSBL. First, the device reset is released. Next, FSBL loads the SSBL parameter and SSBL program, which were stored in external flash memory, and transfers them to the tightly coupled memory, TCM, area built into CPU 0. The transfers are made according to the specification in the SSBL parameter. Then, when the processing of FSBL is completed, it branches to the start address of SSBL program extracted to TCM. SSBL executes the initialization process. It copies the user applications to internal memory and initializes memory, clocks, and modules from the startup code of FSP. The user application is then executed. From here, the flow of FSBL in each boot mode setting is described. Each device supports different boot modes, so please refer to the hardware user's manual for the device you are using. The first boot mode example is XSPI boot. It boots by connecting an external flash memory to XSPI CS0 area with single, dual, quad or octal data signals. Let us take XSPI 0x1 boot as an example. 1. The FSBL sets XSPI according to the program written in boot ROM when the product is shipped. The boot ROM is internal read-only memory holding the FSBL program. The settings in 1 are determined by the mode setting pins, MD2, MD1, and MD0. 2. The FSBL loads the SSBL parameter from the external flash memory and verifies data for errors, checksum. The SSBL parameter is loaded to BTCM. It contains information such as XSPI control signal weight settings, and transfer source and destination addresses. 3. The FSBL executes settings for speeding up XSPI. This setting is designated by the SSBL parameter and sets the parameters. 4. The FSBL loads the SSBL program from external serial flash memory, with XSPI interface to BTCM. 5. It is branched to the start address of SSBL program in BTCM. The second boot mode example is 16-bit and 32-bit bus boot. It boots by connecting external flash memory to CS0 area, with 16 bits or 32 bits data bus. Let us take 16-bit bus boot as an example. 1. The FSBL sets BSC according to the program written in boot ROM when the product is shipped. 2. The FSBL loads the SSBL parameter from the external flash memory, and verifies checksum. The SSBL parameter is loaded to BTCM. It contains information such as reading and writing access wait settings, and transfer source and destination addresses. 3. The FSBL execute settings for speeding up BSC. This setting is designated by the SSBL parameter, and sets the parameters. 4. The FSBL loads the SSBL program from external NOR flash memory, with 16 bits data bus interface to BTCM. 5. It is branched to the start address of SSBL program in BTCM. The third boot mode example is host interface boot. An external host CPU is connected as a master device, and RZ behaves as a slave device. Let us take serial host interface boot as an example. 1. The FSBL of slave device initializes serial host interface and mailbox and semaphore, according to OTP settings and set master MPU. 2. The FSBL of slave device outputs mailbox interrupt to the master device in order to inform the reception ready status. 3. The master device transfers the SSBL parameter to system RAM in the slave device. 4. The SSBL program is transferred in the same way. 5. The FSBL of slave device waits for mailbox interrupt of transfer completion from the master device. It also sets MMPU after receiving the interrupt. 6. The FSBL of slave device verifies checksum, and copies the SSBL program from system RAM to BTCM. 7. It is branched to the start address of the SSBL program in BTCM. 8. The SSBL of slave device executes the SSBL program and outputs mailbox interrupt. This boot mode is not supported in Smart Configurator, but serial host interface sample code is available in RZ N2L. It is available from the link in the summary section of this video. The last boot mode example is RAM execution, which executes without an external flash memory connected. This mode is supported by FSP for debugging. 1. ICE programs the SSBL program to BTCM in RZ/T2N. 2. It is branched to the start address of the SSBL program in BTCM. That's all for the explanation of FSBL flow in each boot mode setting. Next, we will explain how to specify each boot mode with Smart Configurator. XSPIX1 boot, 16-bit bus boot and RAM execution, which are supported by FSP, can be selected when a project file is created. On step device and tool selection, select the combination of board and boot mode you are using from the drop-down list in the board options. Also, when using RSK, the appropriate switch setting for each boot mode must be made. Refer to the user's manual for the RSK you are using.